I'm Frank, it's my best friend Martin. We are here to give you a short talk about bunsen. Now, who here went to the talk 3 years ago at, not you Red Hat people, you don't count. Anyone else? Not you, you don't count. Okay, so that's too bad because I'm going to be repeating all of that again, or not all of it, just summarizing that stuff again. And let's get started. Yes, we have a beautiful logo. Yes, it is. So we're trying to find the holy grail of testing, how to get some kind of tool that'll help us tell developers when they broke something, not bother them any other time, but tell them precisely when they broke something, how they broke something, and try to do it with a minimal amount of human attention and human attention. We've made some progress into this in these past couple of years, so I just want to bring you guys up to date. Test suites. Everyone here works on software with test suites, right? Deja GNU is the standard one for GNU stuff, but there are many other sorts. It's a mess. It's a mess in the sense that each time you have a build, well, obviously you have a particular software version that you're testing, but once you have a build, you end up with 100,000 to 10,000, thousands and thousands of test results. If you're lucky, you have access to multiple build environments, build servers where you have different architectures, different compilers, all of them giving you a whole boatload of passes and fails. You might get, again, if you're lucky, you might get not just passes and fails, but also logs of the exact test suite failures, so you have a chance of figuring out what went wrong. And the problem is that unless you're on one of those very nice watertight projects where you always get 100% passes, in which case, good luck. There's some, not mine, but there are some. They do exist, and my hat would be off if I was wearing a hat, but it's rare. So, and the larger the project is, the larger the test suite is, and the larger the number of failures you would need to analyze, and it's just too much data for humans. So, but maybe we can do it with some more tooling. Again, it's not the first attempt to do this, but we might have found a nice sweet spot, and I'll let you be the judge of that. Bunsen. So again, if someone was here 3 years ago, they would know all this already. There will not be a test, but we'll do just quickly run through this. Bunsen is a two-sided system. On one hand, it is a test suite log capturing system. So it just uses Git as the all-purpose text repository. It, with a single shell script, it lets you identify all the log files that constitute the test suite results after you run make check. And it will copy all those log files, any other metadata you wish to supply, dump them into a Git tree and somewhere else, and tag it and save it. That tag, that commit becomes a permanent identifier of your build, and from there one can retrieve all the log files forever, basically. Because it's a Git tree, it's excellent at compressing text. So for example, on SourceWare, we have a Bunsen database, which has test suite logs that have been collected over months and months and months, and the compression rate of this text stuff is like over 99%. It is just simply incredible how good Git is at this. So we have like 100 megabyte GCC Deja GNU logs compressing down to like 1 or half a meg in the pack. So it is really efficient for text storage. And then you can just dump all this test stuff into our log archive, and
this is how the repository looks like actually, and here you can see the tags, and if we open one, you can see the log file. Later.
Just quickly run through. All right. So all this stuff is real, all this stuff already works. I just want to give people an idea what that is like. So basically use Git as a repository for your test logs. And we provide a place on SourceWare where you can dump your logs. Already all the build bots on SourceWare put all the logs in there for all the projects we already automatically build GCC, glibc, valgrind, alphautils, pretty much everything goes in there already. If you have private builds on your own, you're welcome to also start sending data to this central repository. We'd love more data. All right, so that's for the capturing side. Processing, of course, is what we really want to do. So once that data is in there, little scripts that we ship, it's all GPL code, but you don't have to run this stuff, but you can. The code that is installed on Sourceware then examines all this Git content, which is now enormous masses of text, and it parses out all the passes and fails, indexes it all so that you can very quickly later through tools and the web interface find the fails precisely where they are, find the exact snippet of log that described that particular failure. It cross-indexes portions of the log file and the summary files and the other similar things for the other test suite styles we have. So it basically takes this ginormous Git raw text stuff and turns it into an SQLite database that then can be queried for any further processing. They're very small tools to then use the data from this SQLite database. There's a little baby web interface that lets you also click and operate the various basic operations. The primary one being, you can look at your own builds in the past, you can look at other people's builds, but most importantly, you can compare builds, compare your test results to any number of previous ones or other ones. So this too has been running on Sourceware for several years. The URL is open to the public. You guys can click and see if your favorite project already is feeding data there. Again, we have the capacity to take in a lot more than we already have. All right, now to the holy grail stuff. Software does break once in a while. I have committed some regressions every now and then. I'm sure some of you have. But they're often not obvious, right? Say you have a particular version of the patch that broke something. On one hand, you have the patch, great. But the way you know that the patch broke something is by having someone build it, test it, generated this MOG of test suite data, and then a tool like Bunsen has a chance to find it there. But we don't just have one test, right? If you submit it to one of the Sourceware builders, it'll build it on 20 different architectures right away. It might skip some upstream commits because the building takes 10 hours for a really big test suite run. So you might have 10 upstream commits between each actual test. You also have personal branches which go into the same test repository. So you have a whole random mash of versions that are tested whose results can be analyzed. So when you're trying to find a regression, it's actually a bit of a challenge to just find what you want to compare against what. Because you have multiple versions of multiple tools, multiple historical snapshots on multiple architectures, all of them going together. We have enough metadata to tell them apart, but still it's not obvious which one you want to compare to. You want to compare against multiple relevant ones. That's a job for AI. Did you read my mind already? No, Did you take my brain? Well, but I want to motivate why we want to feed this to an AI system. It's because we have many builds of random versions of an upstream commit history, and all of them getting different test suite results. Which is caused by what? And this is not a trivial thing, and it requires human attention, requires manual searching, integration, and judgment. Yeah. That word is judgment, sorry. Slide is just... Well, doing this manually, right. I mean, if you click through the Bunsen interface as of a couple of months ago, this would be a manual job. Okay, you have to find out which are the relevant other tests. You compare, and then you stare at it and look at the logs and... Okay, anyway, but now we can do a little better. So Bunsen has learned not only the actual test logs that have been fed into it, that metadata also has things like what upstream commits each build was for, because our build bots helpfully supply it, and so do all the other data sources. So for each test run that occurred, we know exactly which upstream Git repo it came from, which upstream Git commit that corresponded to, which is really cool. Because now Bunsen can check out that tree, find the commit history for that tree, and find out all the patches that went into that tree in the recent past. With that, it can find all the other tests that were run somewhere in the recent history of that tree. And there could be multiple of them because they're all the different architectures, all the different compilers. So it can find historical builds that might be several patches away. It can find other builds of the exact same version, which is normal because we test GCC on 10 architectures. And it can do one of these matrix differences kind of thing. And it sounds complicated, but it's really, once we hold the historical test trends we're interested in, and we know what the current test trends are, we can just run a loop, compare all of them against all of them, and then we get a list of deltas, a list of regressions, basically just like lines in a sum file. My God. Okay. And since we also know what patches went in between any of these pairs of test runs, we can also extract the actual patch content, at least the description text, or even the code. And we can now give you a brain icon on the user interface of Bunsen on the web. And what this will do is compute all this massive regression matrix. It'll feed in all the metadata it knows about all of these test runs, so which machine they were built on, what architecture they were on, what version, all the metadata we possibly know, and it's quite a bit. And all the upstream patches connecting any pair of these builds. And then ask the AI to say, please, Mr. AI, pontificate upon this and tell us what may have caused these regressions. And in particular, since the AIs are so gosh darn smart, we can ask them to say, classify them in terms of what is a likely, high likelihood, medium likelihood, low likelihood cause. And we can ask it whether any particular patches may have been high, low, medium likelihood causality. Because it could be either that the patch is totally innocent, it's just that a different environment was the problem, or a compiler breakage that day, or who knows, out of memory. So sometimes non-patch reasons happen for regressions. Anyway, so we ask an AI to please give us a report, and it does that now. You can do that right now. And Red Hat very kindly is sponsoring a high-powered, super-duper AI thingy to answer that question right now on Sourceware. Yes?
So, when you say provide upstream commits, when you say provides upstream commits, Bunsen only has the commit hashes. Where do you get the? Because
the build also included the URL, the Git repo name, so we can actually
it's
clone that sucker. We actually clone only the metadata portion of it, or the tree, or the commit subtree, so we don't waste space. But we can query all of that stuff and then send that also. So we join the test history and we infer the upstream history and we merge them together. And I think that's where this becomes magic. You can say that again. So right now, this is all done, all available via the brain icon. And soon, we're going to be prototyping, courtesy of this fine gentleman, a tool that automatically does this analysis and reports to developers directly via just email if the system thinks that their patch may have been responsible for a regression. We can actually get the LLM to identify those patches which it thinks are high likelihood, and we can send a little discrete email to them saying, you might want to check this out. It'll give a link to the web system so they can analyze it for themselves, and if so, they can.
Just make sure the email message says may have.
Yes. Oh,
not
totally humble.
Really annoy people. Don't do that.
Yeah, and we want to have blacklists so that people can opt out of this, and want to be very, very gentle with this stuff because it is only a stupid AI. It's just, but it's less stupid than you think. It's very interesting. Nick.
So can Bunsen be used pre-commit? Because I would much rather have this run before I do the commit to tell me, no, actually I've forgotten something. But afterwards and get the blamey email saying you're an idiot.
Yes, absolutely. You can do lots of things. You can run this entirely locally on your machine. You can test 2 build trees that you have locally and never touch Sourceware or any other system. It can be totally local.
When you do a try commit, it also puts the results back.
Okay. Over to Mr. Martin, who's be brave and will try to do a demo.
Let's see. So this is the actual Git repository where the testing data are collected. There is a sourceware infrastructure with buildbots which generates test results and uploads it here. And here the story starts. Now, how does bunsen look like? Well, so what I did is that I took part of the repository from sourceware, installed it locally, or git fetched it locally, and ran bunsen on top of it. For the purpose of this demonstration, I only downloaded testing data for Valgrind, but on sourceware there are more projects which are included. So I downloaded the data from sourceware and then ran the bunsen pipeline, and this generated a SQLite database. Both these sources, both the Git and the SQLite database, are used for processing and displaying the data. So right now I open test runs overview. Each test run basically is a set of test logs somehow processed. As you can see, these test data come from various build bots, various architectures. We can do some filtering here. Let's see, maybe we can add, for example, architecture. And here you can see that these test results come from various architectures. How does a test run look like? If we open one, you can see that there are some metadata, including the upstream commit hash, author of the commit, and many other metadata. And then you can start looking deeper into the test results. We have some results here. Now to demonstrate how bunsen works, it is basically composed of a couple of Python scripts which are connected together via JSON, and you can watch the bunsen logs to see what's actually happening here. So I just displayed the test run overview. If you want to hack up some scripts for you to do exactly what you want, you can just look at the logs as a start, and here you can see what bunsen is doing under the hood. So you can see that it's running some Python script. If we run that, it generates some output. You can have a look, how does it look in a nicely formatted way. So you can use this for your own purposes. And all the data are in the Bunsen DB, so it's a relatively lot of, I think, useful data available for everyone to process them as they wish. So now to demonstrate, for example, how regression looks like, I found one actually, so let's demonstrate that. So one of the features we can use here is that we can display a test result of a single test case here. I've just found one which nicely demonstrates what happens or how the regression looks like. So let's open this one, for example, and now we can see test results for this test case. There are many other test cases there, but we just filtered out one of them, and we are looking at its test result. Now let's show more. And now there is a lot of testing data. To show something reasonable, let's just filter out other architectures and look only at one of them. So let's say that we want just to look at this architecture. It gives some results. Now we can see that we have data from various build bots. These data are generated somewhere on sourceware. This were generated by me somewhere else, and all the data are here. Typically, various sources produce various data, and they might not be directly comparable. For example, my build bots are running these tests under root, which is useful for investigating some syscall behavior. The other build bots are running those tests under some regular user, so these test runs might not be directly comparable. So let's filter only the data coming from this source. Okay, so now we can see, if we scroll through this, that this test case was passing at some point. Time is going up in this view. So if we scroll up, we can see that at some point something broke here, and shortly it was fixed again. We can also show the upstream commit hash here. Let's do it by adding this one, and now it becomes, yeah. But we can see that there are some upstream commit hashes, and we can, for example, have a look at the commit that broke it, right? So we can in this case, it's simple because we have test results for every commit in the line, so we can easily identify the problematic commit here. Other feature that bunsen has is looking at some somehow defined neighborhood of a commit. You can take a commit hash and you can ask bunsen, hey, look at the other commits that are close to it and show me the test results that are there. So we can use this feature to investigate the neighborhood of this commit, for example. So we can put the commit hash here. We need to pick a repository and branch so that the neighborhood is somehow defined. And yeah, that looks better. So here you can see that we have some delta, which is the distance from the reference commit to the other commit we are comparing to. Again, we have lots of results here, so we need to somehow filter that out. So let's filter only some interesting architecture again. So let's only filter this. And now we can see that we have test results for one newer commit, one older commit, then the delta of 2 before and after, and delta 3 before and after, and now we can still start investigating here. So I think it's time to finish this. So I now should get to the big feature, which is the AI analysis of the test results. So let's try to show how it works. I open one of the test runs and click this beautiful brain, and it should start doing something. It started, as you can see. Here are some input data, some reference test runs, some ancestor test runs, and upstream commits. Here is the LLM query, which we used to query the LLM system. And here is the answer, which says, or somehow summarizes the possible causes of this behavior or regression or whatever. Yeah, I think maybe some questions.
Or some questions outside. I think just throw the.
Okay.
Anyone can have a 30-second question?
Okay.
Cool. We'd be happy to talk afterwards or online or whatever. So I'd love you guys to try this and use it and let us know how it works for you. Brilliant. Great. Thanks.